In advanced math and science, there's a number that shows up quite often called the Euler's constant, and that's actually spelled E-U-L-E-R. It's pronounced Euler, not Euler, and the letter for this constant is E. So, just like how in math you have pi, which is 3.14 something something something, there is another number called Euler's constant, and I won't say exactly what it represents in this video, but I'll just tell you that it's related to how things grow exponentially. So, you know, some people do refer to it as the exponential constant, but it's actually called Euler's number. All right, so when working with this number, it is good to know that the number is approximately equal to, not exactly, but approximately equal to 2.72. It's just a number. Like 5, like 4, like pi, just a number. All right, so we do have to know how to work with log to the base e, but instead of referring to it as log to the base e, we actually refer to it as ln. So whenever you see ln in logarithms, it's just referring to log to the base e. There is a button for log to the base e on your calculator, and it's written as ln. Good news, if you know how to work with logs, regular logs, that means you know how to work with ln. There is actually no difference. Okay, so in this example, I just want to make sure that you understand the whole meaning of that ln. So we're going to find what ln e is. So remember that ln is really the same as log to the base e. So they're really asking in this example, what is log to the base e of e? So let's say log to the base e of e is x. So we're trying to find x. Well, that means that e to the x is equal to e. Remember, the base to the exponent is equal to the answer. So e to the x is equal to e, which means that in this case, x is equal to just 1. Okay, so in this example, we're being asked to simplify this thing that looks wonderfully complicated, but don't worry, it's really not that bad. Alright, so again, ln is really just log to the base e, so if it makes you more comfortable to see that, you can rewrite it that way, of 1 over e squared. Alright, that fraction doesn't have to be a fraction. We can take this number up, and remember what happens to our exponent if we move our value up. The exponent changes signs. So we have log to the base e of e to the negative 2. That exponent changes signs. Alright, now according to our third law of logs, remember that we can take this exponent and put it over here. And we get that this is actually negative 2 log e to the e. Alright, now we did just speak about what log to the base e of e is, right? So if you remember, let's put a side note over here. Remember that log to the base e of e is just equal to 1 because e to the first power is equal to e. So this is really just saying here, negative 2 times 1, which is negative 2. Alright, let's work with a couple more just so you can get comfortable with that ln. Again, it's really the same thing we've been working with our regular logs, but I just want to make sure you're comfortable. Okay, so here we have an expanded log, and we want to get it as a single log. So let's just rewrite this first, and let's start. 2 ln 5 plus ln 4 minus 3. Alright, so the first thing that I want to do to get this into a single log is, according to our third law of logs, I'm going to take this and change it into an exponent. So this is equal to ln 5 squared plus ln 4 minus 3. Alright, so here we have, still, it's an expanded log, and we want it into a single log. So according to our first law of logs, when we're multiplying, remember that, when we're adding, remember it changes it to a multiplication. So we have ln 5 squared times 4, and that is minus 3. All right, so that minus 3 is getting in our way, and we have this number that we can simplify. So let's actually just simplify this number first to get that out of the way. We have ln, 5 squared is 25. 25 times 4 is 100. So we have ln 100 minus 3. All right, so that 3, really annoying. We actually want that 3 to be in ln so we can group things together. So, side note over here, we want to turn, again, this 3 into an ln. So we're going to change it to log to the base e of something, we don't know what yet, will give us 3. So we want to know what ln will give us 3. So log to the base e of x is 3, which means e to the third power is x. So that means we just figured out what that x needs to be. It should be e to the third power. So again, remember we figured that out because we know the base to the exponent gives us that number. So hopefully that's clear. It can get a little confusing, I think, sometimes. So 3 is actually ln e to the third, as we see from the work we did over here, ln e to the third. All right, now according to our second law of logarithms, which hopefully you should know, we are trying to get this into one single log, and since we're subtracting here, we should, in order to get it to a single log, divide. So we get ln 100 over e to the third. And we're done. But just to make absolutely sure, that you completely understand this, I wanted to hit on every single type of log problem that we've done. So I wanted to hit on a problem where we're trying to figure out an exponent. And to figure out an exponent, what do we have to do? Hopefully you remember, we need to take the log of both sides. However, if there is an e in the question, it is easier to take the ln of both sides, the natural log of both sides. So let's go ahead and do that. We're going to take the natural log of e to the 2x and the natural log of 9. Trying to color code and it's just not working out too well. All right, there we go. So we're trying to take the natural log of both sides. Now, in order to solve this, remember that according to the third law, that should be automatic to you now. We can put that over there as a coefficient, and we get 2x ln e is equal to ln 9. All right. We're trying to figure out what x is, so we can isolate this by dividing both sides by ln e. And we get that 2x is equal to ln 9 over ln e. Well, do you remember what ln e is? ln e is actually just 1, so it's actually just divided by 1. We don't even have to write it down. Cool, that's gone. And that's just ln 9. All right, now in order to finish this, we can divide both sides by 2 or multiply both sides by a half, same thing. And we get that x is equal to a half ln 9. We could go even further here, and according to the third law, we can put this bad boy here back up here as an exponent. So we get that x is equal to ln 9 to the half. Now, hopefully you remember that raising something to the power of a half is actually the same as square rooting it. So that's really ln 3, 9 square rooted. All right. At this point, we can just plug directly into our calculator, and we get, when we plug ln 3 into the calculator, it's approximately equal to 1.099. All right. there are so many different ways we could have gone about like going through this problem. For example, we could have just put ln 9 to the half into the calculator. We could have put ln 9 into the calculator and halved it. So there are many ways you could have gone about doing this, but as long as you get this end number here, that means you're good to go.